Hello, welcome back. Now we are on practice number 2, Substractor of 4 bits. So the focus of this design is implement a 4-bit subtractor using an Intel Max 10 FPGA. The 4 subtractor is an essential component in digital systems for performing binary subtraction by accuracy managing borrow operations. By utilizing the Max 10 FPGA, this project aims to demonstrate the effectiveness of the 4-bit subtractor in performing subtraction operations efficiency compared to traditional methods. So, first of all, we have these 3 libraries, the same as all the projects I have been doing in this channel. We have the STD Logic 1164 and STD Logic Unsigned. So, the VHDL code is a simple digital circuit design that implements a subtractor using a behavioral modeling. The subtractor takes 2 n-bit binary inputs, so is the A and the B. These are inputs, STD logic vector, and from n1 down to 0, both of them. And as result, we have the subtraction that is stored on the output vector f. Additionally, the circuit checks for the overflow conditions, which are situations where the result of the subtraction exceeds the representable range of output. So we have these two, the unsigned overflow and the signed overflow. These two are outputs of STD logic. Now the entity block. The entity block defines the interaction of the subtractor. It specifies the subtractor will have 2 n-bit inputs, A and B, and an n-bit output, the F. These are used to signal wherever the result of the subtraction has caused an overflow, either an unsigned or signed context. Now the architecture. We have architecture behavioral. Describes the integral working of the subtractor. The circuit temporarily extends the input vectors A and B by 1 bit by adding a leading 0 before performing the subtraction. This extension allows the circuit to detect an overflow by checking the result of the subtraction exceeds the original bit width. Within the process block, the subtraction A and B is performed. The result is stored in the result signal, which is 1 bit wider than the original input to capture any overflow. The F output is assigned the lower n bit of the result, which represents the actual difference between A and B. So this is all for the VHD code. Now let's jump for the physical part.
Hello, as I promised, we are in the physical part. As you can see, we have this the Max 10 FPGA from Intel, and we have already programmed the VHD code in this FPGA. So basically, this will work as a subtractor. So basically, if I introduce a 1 minus 1, it will be equal to 0. As you can see, this LED is turned off. But if I put 2 minus 1, it will be 1, as you can see. So you can do operations in the range of 4 bits. And if you pass the number of operation, it will be overflow. And you have 2 options there, the unsigned and signed operation. So I'm gonna demonstrate this like 1 minus 7, for example. So we have this overflow, as you can see. So that's basically all for this video. I hope you learned something and see you in the next one.